In video 3, we're going to talk about tangents and circumscribed angles. So first off, a tangent is a line that is in the same plane as the circle that intersects the circle in exactly one point. The tangent line is going to be perpendicular to the radius of the circle as well. And one thing you just want to remember is that if a line is perpendicular to the radius and it goes through a point on the circle, then that means that that line is tangent to the circle. So sometimes you may not know if that is the tangent line, but if you know that the radius is drawn on it and it is perpendicular to that line, then it is a tangent line as well. The point of tangency is this point P where it crosses, I'm going to say that this is line L up here. So our point P is just where it touches and intersects our circle. The circumscribed angle then is an angle that's formed from two common endpoints that are tangent to the same circle. So if you look at my picture over here, the circumscribed angle would be this angle AXB. Something that we need to know that you're going to use quite a bit, the circumscribed angle theorem, is that the circumscribed angle of a circle and its associated central angle are supplementary. So that means that my angle right here, angle X, and angle C, the central angle of the minor angle, is going to be supplementary to each other. This means if we add them together, we can have them equal 180 degrees, and we're going to use that to find some different angle measures. So in number 1, we can see that KM, so change that to a KM, and KN are tangent to our circle C. And so since our C is the center, we know that these two lines right there are the radius, so MC and NC are the radius. We need to find the angle measures of all four of those if the angle K is 3x plus 10 and our angle C is 4x minus 5. We know that those two angles are going to be supplementary to each other, so that's going to be our equation setup. So we've got 3x plus 10 plus 4x minus 5 equals 180. So the 7x we've got, and that would be a plus 5 equals 180. If we subtract our 5 over, we would get 175. And then divided both sides by my 7, and we get x equals 25. So remember, we need to find all the angle measures. So we need the angle K, and angle K is our 3x plus 10. So if we take 3 times 25, that's 75, plus 10, we would get an 85. And my angle KMC is my 90 we've already got, and same with CNK is the 90 from that corner. So angle C is 4x minus 5, so 4 times 25 is 100. Minus 5 is 95 degrees. So there's all four of our angle measures in our picture. All right, just a side note from what we had talked about before is if our central angle right here is 95 degrees, that means that the arc that it is opening up to is also 95 degrees. And if we wanted to find out the arc from M to N, this major arc, we would take 360 minus 95. And that would give us 265 degrees, and that would be for the arc. Now, number 2 is a very long question, but it incorporates a lot of different things in here. So first off, we have that angle P is 48 degrees. So our PAO is, we need to figure out what that angle is. But remember up here it says the PB and PA are going to be tangent to our circle. And those are a couple of the measures. So PAO is 90 degrees and PBO is also 90 degrees. So that's what we've got so far. Next set is BOA, and that's our central angle right here. So if we know that this is 48, we can take 180 minus the 48, and that'll give us our angle O. When we take 180 minus 48, we get 132 degrees. I'm going to try my best to write the measures in there as we go as well. So angle AOB, so A or AOB, is our central angle, so the 132. So angle OBA is this little tiny angle. Now realize that that's not 90 degrees. We need to see this triangle right here, and it's an isosceles triangle because these are the radii of our circle. So if we have an isosceles triangle, this is kind of the picture that we are looking at. Because it's the radius, we know those two base angles will be the same, so we could have 2x plus 132 should equal 180 degrees. So when we solve this, we get 2x equals 48 when we subtract it. So then my x should equal a 24. So both of those angles would be 24 degrees. For angle PBA is only part of our right angle, so it's not 90 degrees. But if we have our 90 degrees is here in this other little, so if the whole thing is 90 degrees and we just showed that this is 24 degrees, we have to take 90 minus 24, and that will give us that remaining angle, and that gives us a 66 degrees. So that little piece is going to be 66 degrees. PAB is going to be the exact same thing because it's the same angle right here on the other side of our circle. So we've got two more. BSA is our inscribed angle on the other side of our circle, but if you notice, we need to look at what the degree is going to be of our arc AB. So our central angle is 132 degrees, so that means this arc is 132. Remember, if we take the angle is going to be half of the arc. So I need to divide the 132 by 2, and I get 66 degrees as well. For the last question is AOP, and that is our 90 degrees we already had previously. That was just a double up question. If we have two tangent segments that intersect outside of our circle, then the lengths of them are going to be congruent to each other. And we can use this to solve our next question. So if we know that these two tangent lines will be congruent, I want you to set up an equation and solve for x. This is what your equation should look like when you subtract your 6x to the other side. We have 4x plus 4 equals 12. Then if you subtract your 4 to the other side, we get 4x equals 8. When you divide both sides by 4, then we get x equals 2. And notice this is just the value of x, and we want to find the lengths of this. If we wanted to find the lengths of the segments, we would have to just plug that back in there. So 10 times 2 is 20, plus 4, so we would have 24 would be the length of AD. AB should be the exact same thing, but if you double check, you get 12, so 6 times 2 is 12, plus 12 again, you do get a 24. So if you ever want to find the lengths of the segments, sometimes you always have to check that as well.